Okay, so the question was, what's the difference between a p-value and a critical value? Are you talking about?
I don't know. I like watching a bunch of videos like Khan Academy and stuff like that because their videos was still confusing me a little bit, and they were talking about the critical value, but then in your homework it was talking about the p-value, and I'm not quite sure.
Okay, so was it in relation to a z-test, a t-test, or a chi-square test? So we're talking about a chi-square test.
Before the quiz.
Yeah.
Go through one example, like as class.
We can do that.
Okay.
So we got lots of time today. That's why I started recording early, because today's a review day, right? So we can take as much time as you want before the quiz. In fact, we could do the whole thing before the quiz if you wanted. Just make sure you give yourself enough time for the quiz. So okay, so Laura, you were watching Khan Academy, and they were referring to critical values.
Yeah.
So yeah, there's two ways to do a problem. I don't like to use the critical value method because in real life, nobody really uses those. But I will say this. Oh, I forgot to turn on the projector here. But kind of the short answer while that's coming up is that the tables, either the t-table, the z-table, the chi-square table, every value in there is considered a critical value. So if we're talking about, for example, a z-test, I'll put z or a t, okay? So the idea here is with either a z or a t test, either with the z equation or the t equation, what are we converting our mean to? We're converting it to 0. So one way to do this, in fact, some of you may like this idea better. I don't like it because I don't memorize critical values. I mean, think about it. Would you like it if I asked you to memorize the z-table, the t-table, and the chi-square table? Yeah, it's ridiculous. Nobody does, okay? But conceptually, in some ways, it can make a lot of sense. So if I'm using either a z or a t-table, let's use z because I do know that one. If we go out 2 standard deviations or 1.96, what is the area in the two tails for the z-table? Let's talk about the z-table specifically. So let me ask it this way. I didn't think that was a hard question. Using the 68, 95, 99 rule, there's your big hint. What is the area in between plus or minus 2? You've got 95%, right? Assuming that we're talking about a z only here. So what's in the tails? You've got 0.025 here, and you've got 0.025 here, which is 5%, right? Okay. So one of the things that you could do is, and let's say that we're doing a two-tailed test. Mu equals, I don't know, 17, mu not equal to 17. Let's say, for example. Okay? So you get a z-score, make up a z-score, I don't care what it is, make it up. Or give me a z-score. You're doing your math, you get a z-score, and your z-score is, what'd you say, 3.29. Okay, so in the context of this graph, where does 3.29 fit? Fits way in the tail, about right there, right? That's your 3.29. Okay, now you can think of it, if I'm in the shaded area, I'm in the rejection region. Okay, so if you don't want to figure out the p-value, which I want you to, by the way, but this is the Khan Academy method, is they say, well, figure out what your critical values are. In this case, my critical values are 1 plus or minus 1.96. If I get a value such as 3.29 in the shaded region, then I'm going to reject. Okay, so if I get a value anywhere greater than 1.96 or less than negative 1.96, I am in my rejection region. The white area, this is do not reject. So let's do another example. Let's say I got a t-score. Well, I don't care, t or z. Z-score equal to 0.5. Where does 0.5 fit on my graph? It's right there, right? Do I reject or do I not reject? Do not reject. Okay, now that's not a method that I taught, but it does work. And some of you who are visual people, you may find this an easier method. That's fine. However, I want the p-value. So let's go, for example, to the z-score. I got a z-score of 3.29. How do I convert that to a p-value? Okay, so I'm going to look it up on my z-chart here.
So basically, your critical value is whatever like your data is.
Okay, well, yeah, we'll keep doing this again. I'll do another. In fact, I'm going to do a chi-square example, and we'll change this. But okay, so I'm looking at the normal distribution table. Okay, I got a value of positive 3.29. So 3.29, I'm over here. So I got the value of 0.9995, right? Okay, is that my p-value? I got 3.29, I'm in my rejection region, right? Okay, what's my p-value? Okay, this is where this comes in handy. So if I draw a picture again, okay, this is 3.29. I want the area to the right and to the left of negative 3.29, correct? So this table is telling me that to the left of this is 0.9995. Is that the area that I want? No, so I want this area here. So 1 minus 0.9995 equals 0.0005, right? So this area here is 0.0005. How much is this area? It's also 0.0005. So if I double that, multiply that times 2, I'm going to get 0.0010. That's my p-value. Now, the method I said is you want to compare to your alpha. Let's assume that alpha is 0.05. Okay? So if I compare that to alpha, do I reject or do I not reject? I'm going to reject. Okay, that's the same answer I got over here. I'm in my rejection region. Okay? Now, the idea here is, let me back up a second. Okay? If my alpha is 0.05, what is my critical value? This is the Khan Academy method, not my method. How do I find that? Because that's probably what your question was, or was it?
Yeah, for the chi-square.
Okay.
For the chi-square, you just do degrees of freedom and your alpha.
Okay, we'll do the chi-square in a
I
minute.
have no idea about the.
Okay, so on this one, if my alpha is 0.05, that goes back to my first picture here. I need to find, so I don't know what those values are, I need to find those two values. So I want 2.5% in the right tail, I want 2.5% in the left tail. Now the easy thing about this is, if I go to my chart here, I have common critical values here. In fact, it does say confidence level critical values. Okay, if I've got 95% confidence, this is 1.96, this is negative 1.96, or I can go fishing around in the table for that. So negative 1.96, look at that, that gives me exactly the left critical value here. Does that make sense? Okay, we'll convert this to a chi-square in just a minute, okay?
Are we supposed to find the critical value now? Or is this like on the test? Are we going after?
I'm not going to ask you that, but she asked me that, and I'm just explaining what it is.
Okay.
So yeah, you don't need to find the critical values per se. Yes, Deborah. How do you know when to multiply it by 2? It's got to be a two-tailed test, and it has to be a z or a t. This does not work with the chi-square because why? Well, we are only doing right tail test, but that's not why.
Oh, it's not symmetric.
It's not symmetric. Because the Z and the T are symmetric, if I find the right tail, this area is exactly the same because of symmetry. Now, on the chi-square test, that's not true, and that's not why you can't do that on the chi-square test. It doesn't work. Okay? All right, so let's do an example with the chi-square test. And in fact, did you have a specific question, Gabrielle, that you wanted to do?
No, I just like wanted to go through one more.
You want me to make one up? Because making one up is a bad idea.
We'll do 5, 6, or 7.
5, 6, or 7, thanks. Okay, so we'll do 5, 6, or 7 off the homework. Do you have a preference? 6? All right, let's do it this way. I hate this one. I'm going to look at it this way. Okay, so homework 21, number 6. Number 6 says, is it true that angry people have more heart disease? Here's the data from all these people, okay? So here's what I'm going to do. I'm going to copy this table. Maybe I'll copy the whole thing. If I can copy it, I'll copy the whole thing. Okay, so if I open up Excel, okay, so I've got here. So how would we, okay, so let's go through our steps. In fact, I'm going to copy the homework here. The homework says identify all the information. Oh. Okay, does part A really apply? Maybe we could apply our alpha. What's our alpha? Alpha equals 0.05. Let's, rather than answer A,
your attention.
Oh,
May I have your attention, please?
okay, everybody under your desks, whatever. Here, I don't care.
Earthquake drill. Thank you.
Okay, take our earthquake drill. Okay, I'm done. Get under your desk. Anyway, if this was real, I'd be, anyway.
Right now, drop, cover, and hold on. Drop to the floor now.
Okay, I
During
did.
a large earthquake, the ground might jerk strongly and knock you down. Take cover under something sturdy to protect
Yeah, I
yourself from
bet.
objects that can be thrown across the room. Hold on to your shelter until the shaking stops. If you can't